Hi everyone, so now we are continuing with our problem solving, and today we're going to do all area problems. So area problems are another type of problem that can be solved using the methods we learned in quadratics. So let's just remind ourselves that the area of a rectangle is length times width. The perimeter of a rectangle is either 2 times length plus width or 2L plus 2W. And the area of a triangle is base times height divided by 2. Or you could think about that as length times width divided by 2, since it's just half of a rectangle. All right, so one leg of a right triangle, so it's a right triangle, is shorter than the other leg. The length of the hypotenuse is 9 centimeters greater than that of the shorter leg. Find the lengths of the three sides. So notice that we have kind of all three sides there's information given to us about all three sides, but they're all based on the length of the shortest leg. So that's what our variable will be. So we'll say let x represent length of shortest side in meters. So that means it doesn't matter how accurate your diagram is. We can label this as x. And then the other one is x plus 1, since it's 1 centimeter longer. And our hypotenuse is 9 centimeters greater than the shortest leg. So find the lengths of the three sides. So now we have to consider, what relationship do we know for the length of the sides in a right angle triangle? There must be a reason why they told us it was a right triangle. Well, in a right triangle, we have the Pythagorean theorem, which is a squared plus b squared equals c squared, where a could be this side, b is this side, and c is the hypotenuse. So we can take these side lengths and sub it in for this equation. Now be careful. A is x, so we have all x squared. But b is x plus 1, so it's all of x plus 1 that becomes squared. So you have to use brackets. Similarly, for c, it's all of x plus 9 that is squared. Now the danger here, this is just x squared. The danger with expanding this binomial and squaring it is that so many students for this write x squared plus 1. But that is not correct, okay? Remember, you have to square the entire bracket or use your knowledge of special products, okay? So this is actually x squared plus 2x plus 1. All right, and this is x plus 9 times x plus 9, which is x squared plus 18x plus 81. All right, so that is crucial that we understand that this trinomial is from that, and this trinomial is that expansion. Okay, so this is a quadratic equation. We have terms on the left and terms on the right that are all quadratic. So we need to collect like terms and move everything over to one side in order for us to use quadratic formula or factoring. So we collect like terms on this side to get 2x squared plus 2x plus 1 equals x squared plus 18x plus 81. And now I move everything over to the other side. So 2x squared minus x squared is x squared. 2x minus 18 is minus 16x. And then 1 minus 81 is negative 80 equals 0. From this form now, we can either factor or use quadratic formula. In this case, it is factorable. If you don't feel like factoring, you can use quadratic formula. However, this is just x minus 20, x plus 4 equals 0. Okay, so either then our x is equal to negative 4, which is inadmissible since we can't have our side length of negative 4 centimeters. So then our x equals 20 must be the correct solution. So therefore, the lengths are 20 centimeters, 21 centimeters, and 29 centimeters. Okay, so you can verify that this works in Pythagorean theorem. Okay, example 2 is a very typical style of area question where you are given 3 sides of a fence or some kind of boundary that are bordered by something like a barn. Okay, so this is going to be a very common style of question. It is very important that you study this question. A fence is being built with one side bordering a barn. So you can imagine here's the barn. All right, and here is the fence. So we only care about 3 sides. So we'll say that there are 2 widths and only 1 length. The farmer has 24 meters of fencing. So that means that altogether, the 2 widths and the length will equal 24. What is the greatest area that can be enclosed? So the area of this is length times width. So they want greatest. So I want the vertex of the area formula. That's what I'm looking for. Now, why can't I find the vertex of this area formula? Greatest area means vertex of area formula. Well, the problem is that I have 2 variables. I have length and width. I need an area equation that just has 1 variable in it, and that's a quadratic, so that I can find the vertex. So instead of having length and width, I'm going to use this relationship here to rewrite length as 24 minus 2w. So I can replace this L with 24 minus 2w instead. So this can replace the L here. So my area is 24 minus 2w times w. Now this is a quadratic with only 1 variable, so I can find the vertex. If I expand, I get negative 2w squared plus 24w. All right, so I want the max area, so I need to find the vertex. So think about it. Vertex is negative b over 2a. There's no need for quadratic formula in this question because we want the vertex. So negative 24 over 2 times negative 2. So that is positive 6. So that means a width of 6 will give the maximum area. So to find what that area is, I simply put 6 into my equation. Minus 2 times 6 squared plus 24 times 6, and that gives me an area of 72 meters squared. Okay, so with 24 meters of fencing, there's a ton of different areas that you could create, but the best one is when the width is 6, this width is 6, so that means the length would be 12, and then you get an area of 6 times 12, or 72 meters squared. So that you can write a sentence. So therefore, the greatest area that can be enclosed with 24 meters of fencing in this situation is 72 square meters. Okay, one more area question, and this is similar to the achievement check that you've done. So a rectangular park measures 100 by 60. So in this case, the 100 is on the outside and the 60 is here. A path of constant width is to be paved around the perimeter. So we can call this the width. So the width is from here to here and from here to here. And this is also the same width. The mayor wants to be sure that the path does not reduce the area of the grass by more than 10%. What is the maximum allowable width of the path rounded to the nearest tenth of a meter? So because we don't want to reduce it more than 10%, first we need to find what our current area is, which is 100 meters by 60 meters. So our current area is 6,000 meters squared. So our new area can only be reduced by 10%. So we take 6,000 and subtract 10%, or 0.1 of 6,000 to find out what our new area is. So that would be 5,400. So we want to find out what width will give this new park an area of 5,400 meters. So our new length is 100 minus 2W, because it was 100, but we're taking out a W on either side. And our width is 60 minus 2W for the same reason. So our area formula then is 100 minus 2W times 60 minus 2W. And we want this area to be equal to 5,400. So we do 100 minus 2W times 60 minus 2W equals 5,400. Now we can see that this is a quadratic equation because when we expand the left side, it will be a quadratic. So our strategy here is to use FOIL, move everything to one side, and then use quadratic formula. So when we FOIL the left side, we get 4x squared minus 320x plus 6,000 equals 5,400. And then we move the 5,400 over to get 4x squared minus 320x plus 600 equals 0. Now, we can put this directly into quadratic formula at this point, but notice that I can actually divide everything by 4. Now, the benefit of doing that is just so that I have smaller numbers to put into quadratic formula. So I can common factor out the 4 and then just use the A, B, and C that are here. So my A is 1, my B is negative 80, and my C is 150. So when we put that through quadratic formula, you get x is equal to 78.1 or x is equal to 1.9. Now notice 78.1 isn't negative, but it's much too large. If you were trying to take this much width away from either side, actually these should say W, then you wouldn't have any park left. So this answer is actually inadmissible because it's much too large. So our solution that we will take is that the width should be 1.9 meters. Okay, so we can verify by checking that that actually does give you an area of 5,400 meters or greater. So if you do that, you get that the area is 5,406.44. So which means that you're reducing less than 10%, which is what the mayor wanted. So therefore, our max width to the nearest tenth is 1.9 meters. All right, guys, so that was, it's a bit of a heavy question. All 3 questions are involving area, but they involve different strategies. So please take a second to review them, jot down any questions you might have or anything that confused you so we can clarify it in class, in the next class. So thanks for watching, guys. Hope you learned lots.